Welcome. So here I go. What I have is secant cubed of x minus secant squared of x minus secant of x plus 1. And what they want us to do is they want us to simplify this problem. So what I want to do for this problem is, kind of look at this and, first of all, see, what can we do? Well, I know that I can rewrite the secant squared by using the Pythagorean identity. And that's really about it. I could rewrite secant squared to be secant times secant squared, and then I could rewrite that using a Pythagorean identity. Well, that's really where I'm kind of stuck right now. But the other thing I can look at this is, what about factoring? Is there any way, a special type of thing I could factor that I maybe might be able to help rewrite the expression? And I noticed there's 4 terms. And even more important about these 4 terms, they all share secant except for the 1. So I can't factor out a secant by using the greatest common factor. But when I have 4 terms, that automatically kind of stops me and say, oh, see if you can factor by grouping. So what we're going to do to factor by grouping, again, is just like what we did with regular polynomials, is we're going to group the first 2 terms and the last 2 terms together. Then I want to see if I can factor by my GCF and see what I can pull out. So over here, I notice that I can pull out a secant squared. So by pulling out a secant squared, I'll be left with a secant of x minus 1. Then over here, I notice, what can I pull out? Well, to make this the same as the secant of x minus 1, I'm going to want to pull out a negative 1. When I pull out a negative 1, I'm left with a positive secant of x minus 1. So now what I notice is between these 2 terms, what I notice is I have these 2 terms are exactly the same. So therefore, I'm going to factor out these 2 terms from, so I'm going to, if you look at these 2 terms, so I have a term here and a term here. Between those 2 terms, they both share a secant of x minus 1. So I can factor that out as my GCF. Therefore, leave me with a secant of x minus 1 times a secant squared of x minus 1. OK, so now what I need to do is see, all right, can I rewrite this using any Pythagorean identity? So we go back to our Pythagorean identity. And the Pythagorean identity that's dealing with secant squared is 1 plus tangent squared of x equals secant squared of x. So therefore, by subtracting 1 on both sides, I have tangent squared of x is going to equal secant squared of x minus 1. So therefore, I can now replace secant squared of x minus 1 with tangent squared. So therefore, I have secant of x minus 1 times tangent squared of x. Now, and let's end the parenthesis there. So for on the end part of this, there's really, I could multiply that through. It's not really going to help me simplify it any further. But this would be your final case. You could always just see if you wanted to multiply it. It's not going to be able to really change any answer. Well, actually, let's take a look at it. Sine over cosine, that will be 1 over cosine. So yeah, that's not really going to give us any more simplified version. Tangent squared of x. So you could either rewrite it in either term, but we noticed that tangent squared times x times secant, that's not really going to help us out any further. So that would be our final simplified version. So there you go, ladies and gentlemen. Hope you enjoyed. Thanks.